And welcome, my friends, to another lesson. In fact, two lessons from Chapter 7. We're going to divide fractions and mixed numbers today. So let's get going. Pause the video, take a look at assignment number 28. Check out your even numbers. The odd answers were already in the back of the book. Check out your evens. Come back when you're ready, please. And so here we go. If you notice from the red to the blue, from the red to the blue, it seems a pretty straightforward transition for today where we already added or subtracted. And I guess I should have written multiplied mixed numbers, multiplied fractions. Today we are going to divide mixed numbers and fractions. Why is that needed? Of course, you'll get to equations eventually where, yeah, you got to get rid of the constant term, but then how do we get rid of 3 and 7/11ths? We'll have to divide both sides by 3 and 7/11ths. Thus, you see where this skill will eventually be needed in more complicated equations. If you wish, get out a piece of paper for some examples. Go ahead and pause the video. Come on back when you're ready. So just to remind you, where you have used the word reciprocal, more likely this year we'll use the word multiplicative inverse, but they are interchangeable for the most part. Two numbers are multiplicative inverses if their product makes 1. So for instance, if you were to multiply 3 over 5 by, you guessed it, 5 over 3, if you multiply straight horizontally, 15 over 15 is a whole. Or if you cross reduce, 3 cross reduces and 5 cross reduces. We could continue on that path. 1 over 6 multiplied by 6 over 1 or 6 wholes. You will, of course, see that the 6 cross reduces to make a whole. What about 5 wholes? Well, yeah, you probably already realized. Convert 5 wholes into 5 over 1, and therefore its multiplicative inverse would be 1 over 5. How about 2 and 1/4? Now, some of you can immediately try to figure that out. Meanwhile, the rest of us might first convert 2 and 1/4 into 9/4, and then it's pretty quickly to see the multiplicative inverse would be 4/9. Now, you ask, why are we talking vocabulary first? And I'm going to skip the video. I will show this in class. I wonder if you remember how to divide fractions. In fact, there is no division in dividing fractions. Instead, well, first we're going to turn 6 wholes into 6 over 1. You multiply by its multiplicative inverse, meaning we convert dividing 2/3 into multiplying by 3/2. Now, forgive me, those of you remember that easily from 6th grade. Others of us needed that refresher. Now, after that, it's just like the lesson from the other day. How do we multiply fractions? You may either go straight into multiplying horizontally and then reduce later. I prefer to reduce first and multiply second. Therefore, while nothing goes into 1 and 3, 2 goes into 2 and 2 goes into 6. Therefore, now when we multiply, 3 times 3 is 9. 1 times 1 is 1. And of course, let's turn that good answer into a great answer and write it as 9 wholes. In like manner, we see 5/8 divided by 25/2. Never touch that first fraction. It is the second fraction where we convert it into multiplying by the multiplicative inverse, which naturally will be 2 over 25. I'm going to choose to reduce early. 5 divided by 5 is 1. 25 divided by 5 is 5. Meanwhile, 8 divided by 2 is 4, and 2 divided by 2 is 1. Now we can multiply. 4 rows of 5 is 20 in the denominator. Meanwhile, 1 row of 1, that neither simplifies nor reduces. So we have it in simplest form. All right, as you may have guessed, algebraic fractions, quite simple. First of all, leave that first fraction alone. Secondly, convert division into multiplication, and we will multiply by the multiplicative inverse, which is y over z. Now again, perhaps you noticed, while there doesn't seem to be anything that goes into both 5x and z other than 1, if you look the other direction, you'll notice they both share a y. Okay, should I do this both ways? Yeah, why not? Some of you would prefer just to go straight into multiplication, where we have 5x times y is 5xy. 3y times z is 3yz. And now you will notice that we could have reduced by y over y. When we do that, 5xy divided by y, well, y divided by y is 1. All the y's cancel out, leaving us with 5x. 3yz divided by y, again, those y's cancel out, leaving 3z. But for those of you wondering, yes, we could have reduced early. Dividing by y, and now look what you have. 5x times 1 is 5x, and 3 times z is 3z. Totally your choice whether to reduce first and multiply second, or multiply first and reduce second. But many of us will choose the more efficient route. First, let's convert the multiplicative inverse of 5a over 6b squared would be 6b squared over 5a. Now we go ahead and say, yep, we have some cross-reducing to do. 3 divided by 3 and 6 divided by 3. Meanwhile, they both share a b as well. B divided by b completely cancels out. Meanwhile, b squared divided by b leaves a single b. Some folks would have just crossed off the 2, and that would be okay. Let's look in the other diagonal direction where we can reduce by 5, 5 divided by 5, and 10 divided by 5. A divided by A and A divided by A. Getting a little messy here, which is why some of you might prefer to multiply first and reduce second. Meanwhile, the rest of us, in the numerator, we have 2 times 2b. 2 times 2 is 4 times a b. In the denominator, we have 1 times 1. Please note in this case, the final answer would be 4b. Now, I kind of wish I would have done this one the long way. 10 times 6, a times b squared. In the denominator, 3 times 5, b times a. I'll go ahead and write it ab. And now with a little disappearing ink here, can I just point out that what is 60 divided by 15? 4 wholes. What is a divided by a? 1. Bye-bye, sayonara, arrivederci, adios, goodbye. And then, of course, a b squared divided by a b, one of those b's would cancel out both the numerator and denominator, leaving us again with 4b. So either direction, that's one of the beautiful parts about mathematics, will get you to the final answer. Meanwhile, let's wrap up now. Pause, rewind if you need to, but for the rest of us, go on and finish up with dividing mixed numbers, where you can probably imagine the first thing we'll do is we will rewrite these as improper fractions. Notice I haven't even changed the division symbol yet. Now I say, okay, there is no division in the dividing of fractions. Instead, we multiply by the multiplicative inverse. Got some quick cost canceling to do here. 5 divided by 5, 5 divided by 5, so that when we multiply, we will get 1 over 2, which is in simplest form. On number 6, again, very first step, simply rewrite. 3 2/3 can be rewritten as 11/3. 1 1/3 can be written as 4/3. Now we will go ahead and recall that dividing fractions essentially means multiplying by the multiplicative inverse, which becomes 3 over 4. Cross-canceling with the 3's, leaving us with 11/4, which is a good answer, but it's not a great answer. There would be our great answer in simplest form. Last but not least, rewrite 8 1/2 as 17 halves. Rewrite 1 3/4 as 7/4. Change that into multiplying by the multiplicative inverse. Some quick cross canceling. 17 sets of 2 or 2 sets of 17 is 34. 1 set of 7 is 7. Convert that. Into simplest form. Now I should have done one more example. I want you to be very careful if you ever have something like this. Let's make it 8 sevenths, 14 thirteenths, because there is going to be a very big, shall we say, temptation to try to cross reduce right away. But please notice, you are not in a position to cross reduce. You cannot cross reduce with anything except for multiplication. Think about what would have happened here. We would have had 8 over 7 times the multiplicative inverse. Please notice they do not both share a 7 in numerator and denominator. That 14 should have been eventually switched down below. So do not cross reduce in any operation except for multiplication. That's my little fair warning. All right, folks, rewind what you need. Otherwise, I shall see you in class. Either you are learning in person with us on Monday, or you are joining us for our Google Meets. That's all I got for today, folks. Take care and let's grow.